Good day. Today, we're going to discuss the measures of variation or dispersion. Measure of variation is a single value that is used to describe the spread of the scores in a distribution. The term variation is also known as variability or dispersion. There are several ways of describing the variation of scores. We have the absolute measures of variation and relative measures of variation. So let's take a look first at the absolute measures of variation. There are five types of absolute measures of variation, which are very important in analyzing the variation or scores or the students in the certain assessment procedures. These are the range, the interquartile range, quartile deviation, variance, and standard deviation. So the range is the simplest and the crudest measure of variation, simplest because only the highest score and the lowest score are needed to be considered. Crudest because only the extreme scores are needed to be utilized without considering the other scores. Okay, so in a set of scores, you just take the highest score and the lowest score. So you're going to subtract it and that will be the range. So the range for ungrouped data will be R equals HS minus LS, where R is the range value, HS is the highest score, LS is the lowest score. Range for group data is also R equals HS minus LS, where R is the range value, HS is the upper boundary of the highest value, and LS will be the lower boundary of the lowest score. So, for the next topic to come, I will give you different examples of this range on how to compute for range. So, let's have this. The measures of variation or the dispersion is the range. So, we have said a while back that it is the difference between the highest score and the lowest score in the distribution. So what are the properties of range? The first one, it is used when the score distribution is normal. Okay, the second one is used when the data are in interval or in ratio level of measurement. The third one is it is used when quick answer is needed. Okay, the fourth one, rough estimation of variation or dispersion. Okay, easily affected by extreme scores, quick and easy to understand. Only two scores are needed to compute the value of range and very easy to compute. Okay, so let's take a look first at the first property. It is used when the score distribution is normal. Okay, of course, we can say that the distribution is normal. It is because we only need the highest score and the lowest score. Okay, so as we can see here, let's take a look on the rough estimation of variation or dispersion. So how dispersed are the scores? Okay, is it homogeneous or heterogeneous? Okay, next is easily affected by extreme scores. Of course, when the highest score is very high and the lowest score is very low, then there will be a big ratio. Okay, next, quick and easy to understand. Yes, it is because you're just going to subtract it. So that is how to compute for the range. You're just going to subtract it. And those are the properties of range. And remember this one, the interpretation of range. So if the range is large, the scores are more dispersed. Okay, what does disperse mean? Meaning the scores are far from each other and it is far from the mean. On the other hand, if the range is small, the scores are less dispersed or less scattered or homogeneous. When we talk about less dispersed, less scattered, or homogeneous, the scores are around the mean. So it is near the mean. Okay, remember that. Next, let's discuss the interquartile range or the IQR. Interquartile range is the difference between the third quartile and the first quartile. And the formula is IQR equals Q3 minus Q1. So interquartile range refers to the distance between the third quartile and the first quartile. And what are the properties? The first one is it is used when the data are in ordinal level of measurement. When we say ordinal level of measurement, this is the second of the four measurement scales. Ordinal indicates order. Ordinal data is quantitative data which have naturally occurring orders, and the difference between is unknown. It can be named, group, and also rank. So what are the levels of measurement? So the levels of measurements are, okay, number one, we have nominal. Okay, when we talk about nominal, this is just the name variables. Ordinal, these are the name plus ordered variables. The third one is the interval, name plus ordered plus a proportionate interval between variables. And the fourth one is a ratio, okay, which is the name ordered plus proportionate interval between variables and can accommodate absolute zero. So what are the examples of nominal data? This can be marital status, type of car owned, okay, shampoo being used, okay. And what about ordinal data? This can be service quality rating, okay, so rankings, okay, orders or scaling, okay. So we have student grades, okay. How about interval data? Interval data's examples are temperature in Fahrenheit, standardized exam score. And the ratio data's example is the height, age, weekly food spending. Okay, so it involves between the differences between measurements, and it is here where true zero exists. So those are the levels of measurement. And interquartile range is used when the data are in ordinal level of measurement. The second one is used when the frequency distribution is irregular or skewed. Okay, so when we talk about irregularity, meaning some of the scores are very low or very high. So next lesson, we're going to talk about the skewness. Okay, and the skewness is a measure of the asymmetry of the probability distribution of a real valued random variables about its mean. Okay, so the skewness can be a positive, zero, negative, or undefined. The third one is reduces the influence of the extreme scores. Okay, so number four considers only the middle 50% of the scores in the distribution. Okay, it is because we're just looking at the middle 50%, since the score that we need to compute for the interquartile deviation is the uh, third quartile and the first quartile. Okay, so the difference between them will be the IQR, and that includes the middle 50%. So it is not easy to calculate as compared to the range, of course, because you have to locate first the third quartile and the first quartile. So don't worry, because I'm going to post in our FB group some of the examples on how to solve of the IQR. Okay, so the next one is the point of dispersion of the scores is the median value. So remember this interpretation. Okay, all of the interpretation must be remembered by you because these are very important in the let. Okay, so what is the interpretation of interquartile range? So the larger the value of IQR, the more dispersed the scores are from the median value. So remember this one. Okay, more dispersed meaning scattered. Okay, kalat ang score. Okay, when we talk about less dispersed, homogeneous, okay, or less scattered, meaning the scores are intact. They are near from each other. Okay, so remember that. Or the smaller the value of IQR, the more clustered the scores are from the median value. So that is the interpretation of interquartile range. Okay? So next, let's have the quartile deviation. Quartile deviation indicates the distance we need to go above and below the median to approximately include the middle 50% of the scores. It is based on the range of the middle 50% of the scores instead of the range of the entire set. Okay, so the formula in computing the value of the quartile deviation is QD equals Q3 minus Q1 over N, where N is the total number of population. Okay, where QD is the quartile deviation value, Q is the value of the first, Q3 is the value of the first, Q1 I mean, is the value of the first quartile, and Q3 is the value of the third quartile. Okay, I'm sorry that 1 and 3 was not placed there. Okay, so the difference between the interquartile range and the quartile deviation is that when we subtract the value of the third quartile to the first quartile, we divide it by the number of population. So what does it mean? Okay, it refers to the average deviation of the third quartile and the first quartile from the value of the median. So what are the properties? It is used when the data are in ordinal level of measurement. Okay, same with the interquartile range. It is used when the score distribution is irregular or skewed. Okay, reduces the influence of the extreme scores, considers only the middle 50% of the scores in the distribution, not easy to calculate as compared to the range, and the point of dispersion of the scores is the median value. Okay, same with the interquartile range. Their only difference is that quartile deviation is divided by the total number of population. So what is the interpretation of quartile deviation? The larger the value of the QD, the more dispersed the scores are from the median value. And the smaller the value of the QD, okay, so the more clustered the scores from the median value. Again, it was not written there or placed there. Okay, so let's have the next one, the standard deviation. The standard deviation is the most important measurement of variation or dispersion. Okay, why? It is because it is the average distance of all the scores that deviates from the mean value. It shows variation about the mean. It is also known as the square root of the variance. So we need to calculate the standard deviation in order for us to easily get the variance. Okay, so the notations for the standard deviation, okay, the symbol there is the standard deviation, the O. Okay, xi is the terms given in the data. Okay, we have there the mean, okay, and the total number of terms. Okay, so what are the properties of standard deviation? The first one, used when the data are in interval or in ratio level of measurement. Okay, so the third and the fourth, okay, levels of measurement. Okay, it is used when the frequency distribution is regular, symmetrical, or normal, as you have seen on the graph while back. Okay, so here. The most important measure of variation or dispersion. Okay, and the most commonly used measure of variation, particularly in research. And it shows variation of the individual scores about the mean. Okay, so again, you have to remember the interpretation. Okay, number one, if the value of standard deviation is large, on the average, the scores in the distribution will be far from the mean. Okay, so meaning the scores will be far from the mean if the SD is large. Therefore, the scores are spread out around the mean value. The distribution is also known as heterogeneous. And if the value of standard deviation is small on the average, the scores in the distribution will be close to the mean. Hence, the scores are less dispersed, or the scores in the distribution are homogeneous. Or remember that. You have to remember that if it is large, meaning the scores are scattered or spread out, okay, or heterogeneous. And if the standard deviation is small, okay, the scores will be close to the mean. Okay, the scores are near to the mean and less dispersed or less scattered, or the scores are homogeneous. Okay, so again, the interpretation of standard deviation, the most accepted interpretation of standard deviation is within one standard deviation below. Okay, the sign is -1 SD, the mean, and one standard deviation above the mean, or +1 SD. In normal distribution, the range between one standard deviation below and above, okay, we have here, the mean contains 68% of the cases. Okay, here, it contains the 68% of the cases. 34% below the mean, so this is the mean, as you can see. 34% below the mean, and 34% above the mean. Okay, here is the sign. Above the mean, below the mean. Within 68%, within the surface, the remaining 52%, okay, the remaining 52% is divided equally between the two tails of the distribution. 16% below the point at -1 SD, and another 16% above the point at +1 SD. Okay? In other words, 68% of the students fall on the average. Okay, so most of the students are here. 16% below average here, and 16% above average. Okay, so that is all about the standard deviation. The variance. Variance is one of the most important measures of variation. It shows variation about the mean. Variance is another measure of variability, which is the square of standard deviation. Okay, so you just have to square the standard deviation, and that will be the variance. And same is true with the standard deviation. You're just going to square root variance. Variance is also called the mean square. One of the sources of variance is the difference between individuals. There's a saying which goes, no two individuals are alike. Even identical twins differ from each other. If a set of observation has no difference, there is no variance. Okay? Remember that. If a set of observation has no difference, there is no variance. Okay? So here is the formula for the variance for the ungrouped data and the grouped data. Okay? Remember that we're going to discuss further about standard deviation and variance. So I will be posting videos again, or some activities or some lecture notes in our FB group in order for you to understand better these different measures of variation. So we have the number 2, the relative measures of variation. The coefficient of variation shows variation relative to the mean. It is used to compare two or more groups of distribution of scores, usually expressed in percent. The smaller the value of the coefficient of variation, the more homogeneous the scores are. On the other hand, the higher the value of the coefficient of variation, the more dispersed the scores are in that particular distribution. And the formula in computing the coefficient of variation is CB equals x over mean times 100, where S is the standard deviation and x is the mean value. Okay? So that is all about the measures of variation. Thank you.